Good afternoon, good evening, or good morning from wherever you're joining us from today. My name is Sarah and I am the Program and Event Manager at the Reactor in Sydney, Australia. Welcome to another Microsoft Reactor live stream event. Tonight I would like to welcome back Phantip and Tanisorn. So Phantip will be starting off this presentation, but I'll give you a bit of background on both speakers to begin with. So Phantip is a Gold Microsoft Learn Student Ambassador, community manager at Spark Tech Thailand, Microsoft certified trainer, educational writer at CAMPHUB, and former intern at Microsoft who likes technology that makes the world a more beautiful place. Tanisorn, who will be speaking later for the second half of this presentation, is also a Gold Microsoft Learn Student Ambassador, AWS Next Gen intern at Amazon Web Services, Azure Musketeer, and SIT student at Thammasat University. This evening, they will be presenting an overview of artificial intelligence and machine learning. You will see I've already added to the comment section a check-in link. Please check in using the event code 14225 for today, and you'll be able to get additional resources from this session that's been provided by both speakers. This session will be approximately 60 minutes with about 10 minutes for questions. However, do send us your questions throughout and we'll try and answer as many as possible. At the conclusion of this session, we will share with you a link to our feedback survey. So if you have a chance to fill that out with the same event code 14225, that would be great. There will also be an on-demand version available of this recording on our YouTube channel within the next 24 to 48 hours. So do keep an eye out, and we have shared that link with you to the YouTube channel on the check-in link. But for now, I'd like to hand the floor over to Phantip to begin. So thank you, and over to you.
Hello, everyone. I would like to welcome you to our session, the overview of artificial intelligence and machine learning. And thank you for joining us today. For this session, you will learn about the overview of artificial intelligence, machine learning models, where is AI being used, and a cognitive service demo that will be centered on using Python and Flask in Visual Studio Code to call REST API to access Azure AI service. So, my name is Phantip Kokilanon. I'm a Go Microsoft Learn Student Ambassador and Microsoft Certified Trainer. I'll be your host for today with Tanisorn.
Hello, my name is Tanisorn Jansamret, also a Go Microsoft Learn Student Ambassador, and yeah, I will be a co-host with Phantip today.
Yeah, so the slide deck and resource will be available on our GitHub soon, so be sure to check it out after the presentation. Let's start with the overview of the artificial intelligence. But before we talk about the overview of artificial intelligence and how it works, let's talk briefly about natural intelligence. If you think about how we as a human process information, it's not that different from AI or artificial intelligence. We take input from the world, sight, sound information, we process that through our model. That is our brain, which has been trained by both nature and nurture. We then respond to that input in what would be termed behavior. And with artificial intelligence, it's much the same. Setting aside the potentially scary robot drawing, we feed our computer data, our computer uses the model we built, and then provide us the answer. The term artificial intelligence was coined by John McCarthy, an American computer scientist in 1956 at the Dartmouth Conference. John McCarthy said that the AI is the science and engineering of making intelligent machines, especially intelligent computer programs. Our definition, AI is program which learn from experience in order to address new situations without explicit instruction. It is a field of computer science dedicated to simulating human intelligence. It is software that imitates human capability. These are all things that most humans do on a day-to-day basis, often subconsciously. We make decisions using the information we have available and our past experience to guide us. We can initially know when something isn't quite right or doesn't fit an expected pattern. We can use sight to experience the world visually. We can communicate by writing and speaking. We are able to engage in dynamic conversation, responding appropriately. So AI is a tool for amplifying human ingenuity. So this slide lists common workload or area of artificial intelligence, which corresponding to the human thread on the previous slide. The key elements include machine learning. This is often the foundational for an AI system and is the way we teach a computer model to make prediction and draw conclusion from data. Anomaly detection, the capability to automatically detect errors or unusual activity in the system. Computer vision, the capability in the software to interpret the world visually through camera, video, and image. Natural language processing, the capability for a computer to interpret written or spoken language and respond in kind. And conversational AI, the capability of a software agent to participate in a conversation. Business around the world already use AI in a wide variety of apps, and intelligent technology is a growing field. And I just want to point out that in many solutions, the workload may overlap. So here's the example of AI. You can see that we use AI in bot and digital assistant, recommendation engine, and smart feeder, and so on. But for example, imagine a conversational AI solution that uses the bot to process an auto insurance claim. The bot rely on some natural language processing capability to make sense of input, such as I want to submit a claim. It may allow user to send a photograph of a damaged vehicle, use computer vision to access the damage, and apply a machine learning model to predict likely repair costs. The bot might also use anomaly detection to identify potentially fraudulent claims. So AI is all enabled by machine learning. Machine learning is a subfield of artificial intelligence. Technically, machine learning is a method of data analysis that automates analytical model building. But we can think of it as a technique to train artificial intelligence system without needing to be specifically programmed. Instead, you can create an algorithm that checks in the data and use statistics to predict an output that reasonably collect. For the benefit, machine learning has many applications, and the possibilities are constantly expanding. Here are some of the top benefits that business have achieved with their machine learning project. First, uncover insight. Machine learning can help identify a pattern or structure within both structured and unstructured data, helping to identify the story the data is telling. The second, improve data integrity. Machine learning is excellent at data mining and can take it a step further, improving its ability over time. The third, enhanced user experience. Adaptive interface, target content, chatbot, and voice-enabled virtual assistant are all examples of how machine learning can help optimize the customer experience. Reduce risk. As fraud tactics constantly change, machine learning keeps pace, monitoring and identifying a new pattern to catch attempt before they successful. Anticipates customer behavior. Machine learning can mine customer-related data to help identifying pattern and behavior, letting you optimize product recommendation and provide the best customer experience possible. The last one, lower cost. One machine learning application is process automation, which can free up time and resource, allowing your team to focus on what matters most. So, how machine learning works? Machine learning is a technique we can use to create predictive model based on relationship in data. So what does this mean? Well, let's look at an example. Suppose a botanist collects some sample of flower. Each sample has some feature such as measurement of the petal, stem, and other details, and the botanist can provide a label for the flower using the species name. The sample data is then processed using an algorithm that tries to find a relationship between the feature and the label. The result of this algorithm is machine learning model. Since the model has learned the relationship between a feature and label, you can use it to predict the species of a flower based on its feature. Okay, quick simple example. So like I said, machine learning works through algorithms that takes in data and use statistics to predict a reasonably correct output. As an example, imagine you are trying to predict whether someone rent or owns their home. To do this, we need a bunch of data about all kinds of people who both rent and own homes. In this example, we have their age, their income, their education level, gender, and of course, whether they own or rent. Remember it in a model. Then we use that model. We put in the feature of the person we are trying to guess about, and the model will give us its best prediction of whether or not that person own or rent their home. So what's the practical difference? If you bought something on the internet and seen related product for you to buy, those suggested products were almost certainly selected using a machine learning algorithm that is packaged into an experience that you, the user, consume. That's an AI. Or if you are on Netflix and you've been watching some show and it suggests other show to check out, they pick up they pick those show using a machine learning algorithm. So terms are often used interchangeably. One funny and true way of remembering the difference is that when you are trying to sell a product, you call it AI. But when you're trying to hire someone to build a product, you call it machine learning. The traditional machine learning model can help answer your question. One of the most common machine learning technique is called regression. You use regression when you want to predict a numerical value like a price, a sale total, or some other measure. Let's look at an example and get an idea of how it works. That's a little mathematics involved, but don't worry, the basic idea is very straightforward. In this example, we will imagine a bicycle rental company that want to predict the number of rental on a given day based on weather condition. We will start with some historical data about cycle rental. For this simple example, we will restrict this to just the temperature and number of rental per day. In reality, there would be more factors to consider. The number of rental is the label we are going to predict, and we are going to use the daily temperature as a feature on which to base the prediction. Generally, we refer to the feature as an X and the label as an Y. And what we are going to do is to try to figure out a function that we can apply to X to get the value of Y. So this function will be the basis of the model that we can use to predict Y for any given value of X. When we find a function, we want to validate it with some data for days, where we already know the number of rental, so we can see how well it predicts. So we will split the data into a subset that we will use to train the model and hold back a subset of validation. To find an appropriate function, let's plot the x and y value so we can visualize the relationship between them. Looking at the plot, you can see a trend in which higher temperature tend to correlate with some rental. In fact, we can fit a line between the plot point that more or less describe this correlation, and we can use this line to work out a calculation that predicts y from x. The ability to use a line like this to define a function for the x-y relationship is technically called linear regression, which sounds complicated, but let's look at the basic principle of how it works, and hopefully you will find that it's actually very intuitive. The point that line intercept and the y-axis is around 35, and the slope of the line is such that for every 1 unit of x, it goes up around 1.5 unit of y. So function that operates on x to find y is 35 plus 1.5 times x. Now we can test the function with the validation data that we have back. Here are the values we get from the function for the temperature on those days, because this is the prediction of y rather than the actual y value. We write it with a little hat and call it y hat. Let's plot the actual value from the validation data along the line from which the predicted value were calculated. Now we can see how well the model predicts by measuring the difference between the predict value and the actual value that we know to be true. This tells us the amount of error in the model. There are various ways to calculate this error value and generate common metric that we can use to evaluate a regression model. So this is a simple example just to describe the general concept and process for training and evaluating a regression model. In a real-world scenario, the training algorithm would need to fit multiple features to a regression function, but the basic principle remains the same. You start with some data that contains feature and label. You use some of the data to train a regression model by using an algorithm that tries to determine a function for x that predicts y. And then you evaluate the trained model using the validation data that you held back. If you're happy with the level of error in the model, you can then use it to infer unknown label value in this case. Next is regression is a form of supervised machine learning. In other words, it relies on us having some data with no label value that we can fit to a model, which can then be applied to new data for which we don't have the label value. So now, let's look at another type of supervised machine learning, the classification. Again, there's some mathematical involved, in particularly probability. But don't worry too much about the details. Just remember the probability is always a value between 0 and 1, where 1 means a definite, 100% certainty. Just as with regression, we start with some data that includes feature and no label. In this case, the feature are medical measurement that might be taken during a health checkup, such as weight, high blood pressure, and so on. This time, the label isn't a numeric value, but an indicator of whether the patient is diabetic or not. The label indicates to which class the patient belongs, diabetic or non-diabetic. In the first column, the values are vector of diagnostic measurement. The second column contains a 1 or 0. Once again, we split the data into the subset of training and validation. Now, we will take the training value and apply an algorithm that fits them to a function so that the y value is between 0 and 1, like this. Since the value can be anywhere between 0 and 1, a threshold value is used to determine the cutoff point where the class is considered to be 0 or 1. In this case, all patients with a feature producing a value greater than 0.5 are diabetic, and those with value between the threshold are not. Function we fit to the data is an example of a logistic function. You can think of the value as representing the probability that the class is 1. Having determined a function that fits our feature or model is produced, and we can use the validation data we have back to test it. Here are the results of applying the logistic model to our validation. The function returns the probability that the class is 1 or positive as a value between 1 and 0 and 1. And since there are only two possible classes, and there's 100% probability that the patient is one of them, the probability that the class is 0 or negative is known. Is also known. The class with the highest probability is the predict value for y. So let's look at the first validation case. In this case, the predict class label is 0, and the actual label is also 0. So the model got it right. It's a true negative. The second case results in the prediction of 1 for the actual value of 1. So again, it's correct. This time it's a true positive. The third case, the prediction is 1, but the actual value is 0. So the model got this one wrong. It's a false positive. The fourth one is also wrong. This time a false negative. To evaluate the model, we tabulate the prediction result in a format called a confusion metric like this. In the real scenario, you use much more validation data than we have on this slide, so it might end up looking something like this. If we apply a heat map to this, intensifying the cell in the metric to reflect the value, you can easily see that the correct prediction in the true positive and true negative cells from a dark diagonal line from top left to bottom right, indicating that the model got more prediction right than wrong. So from the prediction value in the confusion metric, you can calculate multiple metrics that can be used to measure the performance of the model. Regression and classification are both forms of supervised machine learning. Now, let's look at the form of unsupervised machine learning, the clustering. Suppose we collect some observation of flower, noting a number of petals for each sample. What we want to do is group flowers that are similar together, but we have no label that we can use to train a model. Instead, we think of the feature value that we have as being coordinate on which we can plot to sample data point. In this case, we have two features, high and petal, so we can plot them on a two-dimensional grid like this. Now, we need to decide how many clusters we want to group the observation into. This value is generally referred to as a K, and we simply assign K point at random location on our grid like this. In this case, we use a K value of 3, so we end up with 3 clusters. Each of the K point we plot will be centroid for a cluster, so we assign the sample data point to its nearest centroid. Now, we move each centroid to the middle of the point in the cluster based on the mean distance. Now that centroid have moved, some sample point might be nearer to a different centroid from the one they are currently allocated to. So we relocate the sample to that nearest centroid. And then we just repeat the process until the clusters are stable, or we reach a predetermined maximum number of iterations. In this case, the cluster soon stabilize as well-separated group of related flowers. This clustering technique which uses K centroid and move them to the mean distance between their data point is also known as a K-mean clustering. So, if you really want to get sophisticated, Microsoft have a whole bunch of pre-trained algorithms for build your own custom machine learning model. But that's more like data science workshop. If you want to learn more, you can download this machine learning cheat sheet at the link aka.ms/ml cheat sheet. And if you want to learn more, you can export the AI and ML learning part on Microsoft Learn. It's available for free on Microsoft Learn website. Just go to the microsoft.com/learn and you can filter the learning part, the role that you want to become, and or you can filter the Azure machine learning service. And here's my suggested resources. And then I will hand over to Tanisorn about the example of AI in action. Thank you.
Okay. Thank you, Phantip, for sharing about the overview of AI and ML. So now we move to the next point before the demo, which is where is AI being used. And I'm going to show you some business use case that they are using AI in their business to let you see some idea that we can use AI in the business. And let's start with Progressive. As we know, Progressive is the business of insurance provider in the US. They wanted to take advantage of customer increasing use of mobile channel to interact with the brand. As mobile become a more important channel, Progressive has looked for ways to use it to connect with customer who want easy, personal, and trustworthy digital experience. The insurer has found that Microsoft Azure Bot Service and Cognitive Service API also make it easy to adapt and refine the bot, and it respond without needing data scientist to write a complex code. The API also provide the ability for knowledge base to grow and learn more over time, making the response better and better. So they use Microsoft Azure Bot Service and Cognitive Service to quickly and easily build the Flow chatbot, and currently available through Messenger at their Facebook, which answer the customer question, provide insurance quote, and even offer a bit of witty banter in Flow popular well-known style. The next business that I bring today is Uber. Uber use Azure Cognitive Service Face API to help ensure that the driver using the app met the account on file, both to protect the rider and to help ensure that the driver account haven't been compromised. User decide to add photo matching technology to an array of screening method that is used. And Uber turned to Microsoft for performance, accuracy, and scalability of the Face API in Cognitive Service, which can compare photo and return match within milliseconds, even from a photo that might not be the highest quality. If the match is unsuccessful, the Uber platform using Azure Cognitive Service is smart enough to notice. For example, the problem may reflection from eyeglasses, and it will ask the driver to remove their eyeglasses and take the picture again. And about the Microsoft aim to democratizing AI, Microsoft stand is use AI to enable and empower everyone, and Microsoft is doing this in the three main ways. The first one is create a product that use AI in innovative way, enable our user. The second is to building tool that developer such as yourself can use to create. And the third one is actively contributing to the global dialogue of ethical implication of AI. And we believe AI should augment human capability, help us eliminate mundane and repetitive tasks, and instead be more productive and creative. Harnessing its potential also require us to adapt an open and questioning mindset, and we have a shared responsibility to ensure that the model that we build are fair, reliable, and safe, private and secure, inclusive, transparent, and accountable. Next one is Microsoft AI for Good. As computer can help people make better decision through AI. Computers are very good at remember things absent the system failure. Computer never forget. They are better at probabilistic reasoning than most people, which is powerful for making useful prediction and classification. And finally, computer excel at discerning pattern in data that are too subtle for people to notice. This computational intelligence that computer can provide and can have a significant impact in almost any field which human intelligence has a role to play. For this reason, Microsoft seeks to combine the capability of computer with human capability to enable people to achieve more. And AI for Good is Microsoft commitment to providing technology, resource, and expertise to empower those working to solve humanitarian issues and create a more sustainable and accessible world. And Microsoft worked with a company called Why Me on the project called Ybook. Ybook is an open source framework for wildlife data management that seeks to identify and track specific individual animal from a dangerous species in the wild. Ybook use Azure Cognitive Service to do this. To detect and identify not only animal based on their species, but also use the custom vision plus the custom model to identify the individual animal based on the unique trail. For example, zebra have specific strip pattern, elephant have wrinkle, and whale have unique ridges on their tail. So every type of animal needs a specifically trained model that can be used for making and recapturing that animal. And for AI in use in Thailand, and during COVID-19 situation in Thailand, while all of Thai people would like to get vaccine as soon as possible, good vaccination flow management is one of the key factors that help us to achieve the goal and can help people. In Thailand, we have a project called HackWack that they use the power of AI to manage the vaccination flow for the vaccine hub in Thailand, in Bangkok. They use the cognitive service to capture the image from CCTV to analyze the traffic and flow management. The system will detect popularity of people in the area and let the people know which zone they should go with no long time to wait to get the vaccine. And before I go to the demo, I would like to introduce a bit about the principle of responsible AI. When we talk about AI, we usually mean a machine learning model that is used within the system to automate something. For example, a self-driving car can take image from sensor. A machine learning model can use this image to make a prediction. And these predictions are used by the car to make a decision. We refer to this whole system as AI. And this is just one example. AI can be used for anything from insurance underwriting to detecting cancer, the defining characteristic that is limited, no human input into the decision made by the system. This can lead to many potential issues, and companies need to define a clear approach to using AI responsible. Responsible AI is a government framework aimed to doing exactly that. And at Microsoft, AI software development is guided by a set of 6 principles of responsible AI. Let's start with fairness. AI systems should treat all people fairly. For example, support you create a machine learning model to support a loan approval application for a bank. The model should make a prediction of whether or not the loan should be approved without incorporating any bias based on gender, ethnicity, or other factor that might result in an unfair advantage or disadvantage to a specific group of applicants. Second one is reliability and safety. AI system should perform reliability and safety. For example, consider AI-based software system for autonomous vehicle or machine learning model that diagnose patient symptom or recommend prescription. Unreliability in this kind of system can result in substantial risk of human life. The next one is privacy and security. An AI system should be secure and respect privacy. The machine learning model on which AI systems are based rely on large volume of data, which may contain personal detail that must be kept private. Even after the model are trained and the system is in production, it's used new data to make prediction or take action that may be subject to privacy or security concern. The first one is inclusiveness. AI system should empower everyone and engage people. AI should bring benefit to all parts of society, regardless of physical ability, gender, sexual orientation, or other factor. About the transparency, the AI system should be understandable. Users should be made fully aware of the purpose of the system, how it works, and what limitation may be expected. And for the last one of principle of responsible AI is accountability. People should be accountable for AI system. Designer and developer of AI based on solution should work within a framework of governance and organization principle that ensure the solution meet ethical and legal standards that are clearly defined. Okay, and for the next part is the demo. For the demo today, I will focus on cognitive service, and I will show you the idea on how we use the AI to implement with our application, and I have some website to show you today. And moreover, I also created a web application to let you try with me. But start with the first one. Microsoft being Visual Search. They have some library of specialized skill that you can try on this website, like text recognition or find the name of someone that that you might forgot their name. You can also try with me by go to Microsoft Bing Visual Search, and I will try on who is that on the Microsoft Bing Visual Search here. Yeah, and I will upload the image from my computer, which is the Mark Zuckerberg here, and the system will detect the face, and then it can return the result like, okay, for this image that I uploaded, it look like Mark Zuckerberg, CEO of Facebook, something like this. For the next one is about the face verification to check the likelihood that two faces belong to the same person and receive a confidence score. You can try on the homepage of Cognitive Service on Microsoft website. And for the example you said of face verification in cognitive service can be used to apply to verify the person from an image compared to the ID card to process the verification step. And yeah, we see some example of the web application that using cognitive service behind. And on this, I try to upload an image, and we can see that Microsoft Cognitive Service are return the result in JSON format for each person that I upload, and they have a lot of information returned. For example, like attribute of the gender of sunglasses, the age, the mood, like anger, fear, happiness, sadness, natural or emotional recognition, and they also have like face identification. And we also see that Azure Cognitive Service is easy to use. We can use the API to get the JSON file, and we can use this information to develop our application in the next step. And for my demo, this demo application I have deployed to Microsoft Azure. The idea of application is this website is called Contoso Travel, and the idea of this application is when you travel, you will be able to upload a photo of street sign or some sign that you taken from the phone and see the translation. And in the meantime, if you would like to try with me, you can go to the website that I will show you on the screen. And yes, it's time to try. I have a Contoso website here, and then the website will ask me to select the language that I would like to translate to. And for this time, I will go with the Japanese, and then I try to upload an image. Okay. The image that I will upload it. This one is contain the text chance in English, and after we upload, behind this website, it will extract the text chance on the image, and then it will translate to the language that I select before. And yeah, you can see the result in the Japanese translation here. Okay, and let me walk through a little bit about the behind of Contoso website. Behind this web application, there are the Python application and Flask framework that enable us to do Python web application at the front end. The website asks us to upload an image to the app, and after we upload an image, it will let cognitive service to extract the text from an image and then translate to selected language. And after that, cognitive service will return the result back to us and show on the website. And if you would like to create your own first AI web application like this, we can see that this application is not too complicated to try. Let me go deeper a little bit about the cognitive service. And to create a cognitive service, there are two ways to create. The first one is create by using Azure Portal, and the second way is create by using Azure CLI. And to create Azure Cognitive Service by using Azure Portal, you can log into your Azure account. And when you are at the portal, you can click on create a resource and search for Cognitive Service. Then you can select your subscription, resource group, select the region, and then input the name of your cognitive service and select your pricing tier. Then you can click review and you can create. And as in Contoso travel website, we use cognitive service by call the API. That is required to have a key and endpoint URL to access the cognitive service. And to get the key and to get the endpoint, you can go to the cognitive service that you created, and in the resource management menu, there is key and endpoint menu. You can click on it and get your key and endpoint URL from this. And the second way to create your cognitive service is create by Azure CLI. Most operation in Azure can be performed by using either the CLI or Azure Portal. the power user tend to prefer the CLI in pass because CLI command can be used in script to automate repetitive tasks, and it is possible to install the Azure CLI locally on your system with version available for Windows, for Mac OS, and Linux. Okay, and to create a cognitive service by using Azure CLI, start with AC login to log into your Azure account. But if you are using Azure Cloud Shell, there is no need to log in again. And after you log into the Azure CLI, then you may need to install the extension in the Cloud Shell or terminal or command window you are using to access the Azure CLI. Install AC hack by executing of the command AC extension add that name hack. Yes, and after we install the extension hack, we will execute AC hack by create a specific runtime of like Python, allocation of REST US2, and enable AI through the cognitive service. After we run the command to create a cognitive service by using Azure CLI, what did the command do for us? Yeah, for the result show here, the first is to create a key for cognitive service, which we will use for computer vision, translation, and for the website creation and configuration. The command create a free app service plan, create a website for us in app service, and config local Git deployment, which we will use when it's time to make our website public, and then config app setting, which are accessible as environment variable in our website code. And we go back to the Azure portal in the resource group, and we can see that on this page is contain app service plan, cognitive service, and app service for our front end website that we create we can create from both Azure CLI or Azure portal. Yeah, and that I show you about like how it's work for my Contoso travel website. We have Python and Flask to do for front end web application, and then we upload an image to the cognitive service and extract the text and translate. Then results show back on the website. Yeah, and if you would like to deploy your own Contoso website, you can go to the Microsoft Reactor GitHub. There are a lot of resources to learn it and explore, including this demo too. You can go to Microsoft Reactor GitHub, and then you can go to workshop resource. There are step-by-step hand-on with single-step explanation to let you try your own deployment. And as Phantip mentioned, you can learn more about the AI and ML on the Microsoft learning path that we provide. And if you have any question, we are open for Q&A session.
Great, thanks, Tanisorn. We'll just give everyone a minute to see if they have any questions. In the meantime, I believe that Phantip has answered a handful of questions that have come through whilst you were speaking. And in addition, I've just put in a link there to our feedback survey with the event code 14225, and also again the check-in link for today, which is the event code for that one as well as 14225. So if you can go into that link and get the additional resources from today's session that you would have seen throughout the presentation. It appears that all questions have, I guess, been answered throughout your presentation. So I just wanted to say thank you again to Tanisorn and Phantip for joining us today from all the way from Thailand, and to everyone else wherever you're joining us from around the world. Have a good rest of your afternoon, evening or morning, and we'll see you next time for another Microsoft Reactor live stream event. Thank you both.
Thank you.
Thank you.